to know more about us, you can also follow us on the Sahaj LinkedIn page. To know more such events on this Dev Day, you can also follow you can also follow the meetup page, just like how you guys did for this. And also, you can use your washroom there. You can go through that side and you can use it there. To know if you want any more assistance, you can actually talk to our guys and get it. Okay, before taking much time, I would like to introduce our today's speaker, Shankar, who is here to guide us on how to write better code. Welcome, Shankar. Stage is yours.
Thank you. So, hello everyone. So, I'll be talking today about clean code 101. That is your first touch to write code. So, before we move on into our topic, I'd like to introduce myself. So, as AB told, my name is Shankar. So, my hobbies are I listen to music, I like to play badminton, and I binge watch movies a lot, especially over weekends. So, with that said, I'd like this session to be a bit more interactive so that we can gain more insights on, and if we share our thoughts, it will be better. And feel free to ask questions anytime. So, with that said, let's go on. So, what is a code smell? So, it's not code plus smell, but the word says code smell. But so, it is code smell is basically a deeper problem in our application or code base, which tends to cause a problem not necessarily at the same instant, but over the period of time. These code smells, when they get accumulated, they cause deeper problems in our code base. Some of the so basically these code smells can be like design problems in our application. So some of the examples of code smells are duplicate code, even dead code. So these are just the basic examples of what code smells looks like. So the design problem. So we said that code smell is a problem with the design. When it is a problem with the design, I mean that these design problems could probably lead to bugs or lack of readability. So in today's world, like when we write code, it's almost in a basis where we write the code once and then we read it many times. For example, we send it for a review. We get a review before merging the code into our master branch, and then somebody else would be developing some feature on top of our code. So readability is one of the main aspects which code smell affects. So does that mean code smell is an error, or does having code smells in your code base doesn't compile your code? No. So code smells are just like I told, it's just a design problem. They will compile and they will work as expected. So as I said, so a code base which has a lot of these code smells or these problems can inherently lead to bugs in the future. So resolving a bug in the future is not good, right? Like writing a good code or better code today is better than resolving a bug tomorrow. So you guys must have seen this meme. So when you change something and something else breaks, so that is a wonder. Which I think developers who are writing code on a daily basis would know. Okay. So let us look at the effects of code smell. So you can see the graph. So this graph is taken from the book Clean Code. So what happens is initially when we start the project, our productivity will be very high because there is no code. When we start writing code if your code smells tend to surface more and more in your application, what will happen is basically your productivity will gradually reduce over time. So the same, for instance, if the same problem, say for example a feature A, which was given to you on a greenfield project, takes X amount of effort, it would not be the same when time goes on. So because these code smells as I said earlier, they are design problems which are going to affect the extensibility or maintainability of the application. So looking at a developer's point of view for this code smell, so developer's perspective is that sometimes code smells are known, and because of delivery pressure, or sometimes because of the feature being released into this thing, we tend to make these mistakes, that is these code smells, and knowing them that they are code smells and making them is okay rather than not knowing them. So we might have, so after knowing them, you might come back and fix it in some other point, right? So that is one thing. Has everyone heard about the term go slow to go fast? Has anyone? So it's basically a term which is used in car racing, where in a track, when the car when a race car has to make a turn, they tend to hit the brake, because if only when they tend to hit the brake, the car will take a smooth turn, or else what will happen is either the car will be rashly wrecked into the wrecked, or even if if are able to make the turn, sometimes what might happen is the car might not be stable enough to gain that speed back. So that is so I could compare that instance here. So when we see that there is a gradual decline in our productivity with these post mills, it is an indication that we need to fix it at that point, so that we do not fall into this problem. So it's a code given by told by Martin Fowler. So any fool can write code that a computer can understand. Basically, any code which we write, at the end of the day, it's going to be some binary which the computer will understand whatever we have written. But only good programmers can write code that humans can understand. So with that in mind, let us move on to the better code. So what does better code give us? So understandability. So a good code, that is a clean code, should be as easy as reading a normal sentence in a language. So it is so fluent that we do not have any problem in reading it. That has to be that is a very good characteristics of this clean code. So it has to be maintainable and extensible. So every code in today's world, no software, we cannot say that this is a piece of requirement given to us and this is the requirement I'm going to build. It is not going to be like that. Today we get a requirement, and tomorrow what might happen is the requirement might change. So the code has to be easily extensible and it has to be maintainable also. So the reusability point is it should be as much as reusable, because we know that the lesser the code we write, the lesser the problems we tend to occur. So for this talk, I have created a simple use case where I will be showing you a couple of code smells in the upcoming slides. These code smells, I would like to explain these code smells with this example. This is basically a shopkeeper who's trying to get help from us to write a simple application as a billing counter. So the requirements are that he needs to determine the bill amount. That is the total amount which is going to be got at the end. And he is saying that he can give up to 10% of discount for customers who can shop more than rupees 10,000. So this is the base requirement. I'll be showing a couple of examples of code which we have written, which is written, and I'll point out the code smells, and we can show the better clean code. Just a minute. So, uh, so this is the function which is written. So, can somebody, is this code readable? Can somebody say that if this code is understandable? I'll just give a minute for you guys to see through it. Okay. Okay, I see a couple of people saying yes and a couple of people still reading through. So with these comments, say these comments were actually written in the code on top of the functions or on top of the logic, would it have made this code better or readable? So, so, so should the comments be, so as we said, so comments are also part of smell, which means that your code is not readable and therefore you're writing some comments on top of your code which we have written, right? So, so what will happen is today the function is, so we saw the basic function, but with the comments it was readable. But what happens is, as we told earlier, it is not going to be the same always, right? Like you keep getting new requirements and you have to satisfy them. So what happens when we add more code to the same function, that is the process order function? So the example which I've written is managing the inventory and printing the entire contents of the bill. That is what we get in an actual bill, the total price, quantity, and everything. So if you see, I know that this code is very hard to read. It will take quite some time to understand what this code is actually doing. So this is an example of what CodeSmell does. Given that if I had written and you guys were the one to read it, it is not. It is very hard to read. So from the previous piece of code which I showed, I could make sure, I could say that that function was very long. Uh, so it was like very long. I think it was 25 to 30 lines of code. So I'm saying that the function is very long. Is there any objections with that? Yes or no? Okay. So then, what do you guys think that the number of lines for a function should be? Any random guesses or we have 25 words. Huh? 10 to 15. Okay. So we have 25, 10 to 15. Okay. So there's another code which I have taken from the clean code. So the code is, the first rule of functions is that they should be small, and the second rule of functions is that they should be even smaller. So basically, more than the number of lines, a function should be considered doing just one thing. The one thing can be it can be abstract or it can be precise to a particular thing. So a particular term. Uh, and let's see how many things did the previous code. So this was the original code, not the smell, the one with the very big one. So if you see here, this function is doing 4 different things: calculating the total price, calculating the discount, calculate the bags required, or printing the bill. So, so basically, this function is doing 4 different things, and that is why that is why I am saying that this function is a good smell. So let us look at ways where we can make this function look a bit better. So doing just one thing. Now, if you see that we have a function called as calculate total price, which is calculating the total price, is eligible for discount, which checks for the discount criteria which the requirement says, and we are calculating discount with print bill. So with these functions, so they are very simple in terms that the name of the function exactly tells us what the internals of this thing, the function is doing. Basically, calculate total price. If you read the name of the function, it is very readable. So you can say that calculate total price for the list of items in the basket. Yes. So the similar way, so they are self-explanatory. So that is the other key thing which adds to a function. So these smaller blocks of code, they are self-explanatory, that they can be used in multiple places. It's like plug and play kind of thing, where you can use these small functions, you can call these small functions and use it in functionality in a larger function. And then they are easily unit testable. So coming to the point of unit testing, so why do I say that they are easily unit testable? So let us look at the previous code. So to write a unit test for this function, so the process order is basically taking a list of items, that is the basket and is bag required. But internally, we are trying to calculate the total price, the discount if bag is required, and the total price. But what we can unit test is basically you can unit test only the final part, that is if the total price is what you are trying to achieve. So if there's a failure, say here instead of star I have put something like a plus symbol. What might happen is that your unit test will be like it will be like you'll be passing the list of items and this thing, and the bag is bag required, the boolean value. But what you will never know, it's not like you'll never know, it's that it'll be very hard for you to go through. You'll have to debug the code, and you'll have to find where exactly that you have to. It's difficult to locate the problem in this. So from that aspect, that I'm saying that these function, if you see this function, so the calculate total price is exactly taking in what it needs, and it is returning the total price. So with this, I'll be able to test what I require exactly. So we spoke about unit testing, so it's better that we cover what unit testing gives us. So basically, whenever we make changes to, or we refactor the code or make changes, it is always better to have unit tests in place, because they guarantee, they verify the behavior. They see if what is written is exactly what it behaves like. So the verification of the behavior is one of the biggest advantages, and better organization of code. So if you see in the previous slides where when I showed you the problem, the difficulty with unit testing that function. So in this function, the difficulty with, so say for example, there's a problem with calculating discount here. So it is not clearly visible. Why I'm saying that it is not clearly visible is that, so my list of items, that is my basket, is going to control this total price. So basically the basket is going to control the eligibility for the discount. So for example, if the total price of my basket sums up to 9,990 by mistake, which it was like 11,000, and it comes to 9,990 or something like that, the unit test would be failing, and it will be very hard to find where it is. So in that way, so unit test gives you a better organization of the code from that point, and time. So I've been telling multiple times that there is problem and there is the debugging takes more time. So saving a lot of unit test helps us save a lot of times in debugging these problems without even actually debugging. If you know if your function is doing just one thing, you know that the point of failure is just one. If that is not the case, then your unit test is wrong. So can somebody, so can we, so this is a snippet which I've taken from the previous one. So is eligible for discount and calculate discount. So these two functions, I see a problem with these two functions. Can we make this better? Or do you guys see a problem here? Okay, I see a few people nodding their heads. Yes. So basically, there were a couple of magic numbers if you saw in the previous one. How will I know that the value 10,000 is going to be the discount base for discount? Why? So if I'm a new person to seeing this code, and total price multiplied by 0.1, 0.1 doesn't make a lot of sense, right? So extracting them to some constants like this, like is base price for discount is, you can basically extract the value into a constant so that that constants can be used instead. So if you see here, is eligible for discount, return total price greater than base price for discount. So this gives more this from this aspect. If I read it, it is more like a sentence rather than it being some number, random number. Okay. So to explain the other code smells, I'll be picking up new requirements since we are in the world where software development is an agile process. So the new requirement is that for the clearance sale, a clearance sale has to be live for the last 15 days of the year. So the year-end sale, which they have given is 20% for high spenders. That is the people who purchase with a total amount greater than 10,000. They are I've termed them as high spenders. They get a discount of 10%. So this is the code I have written. So if you see here, there are a couple of problems. One is that I say that this function is long, but more than the function being long, there is another problem. That is the conditional logic. If you see here, there is an if statement, there is another if statement, and there is some logic being done. So if even if I had not told you what the requirement was, and if I just shown you this code, it would have been very difficult for you guys to understand this. So the power which the if-else statement takes. So there is an effect which the conditional logic generally has. So when you are figuring out what the condition was, when you are figuring out the if block, we tend to forget what the condition was, and when we are figuring out what the else block, we tend to forget what the if block was. Has everybody or anybody faced this problem? So we have few people. So actually, can somebody look into this code? So I'm not sure if you guys have read through this. I'll give you a minute's time. Can you read through this code and realize that there's a problem with this code? You guys know the requirement, right? 20% say percentage for the sale discount and 10% for people who purchase with a greater amount, total amount greater than 10,000. I'll just point it out. So the else block, actually that else block was not even supposed to be there because so in this case the requirement which I told was we get if you are in a sale period and you purchase with an amount total amount greater than 10,000, you get 30% discount. But with the else block being there, you either get the 10,000 the 10% discount or the 20% discount. So you see that this conditional when writing with this conditional logic, we tend to make so many mistakes. So I'd like to. So we saw in the previous slide that the conditional logic is very consuming a lot of computational power. Like we need the context switching and everything is very hard, right? So what I made here is that I have basically taken out the logic which the condition for the sale so is within sale period. That is basically the function. So that the condition is extracted to a separate function. If you see here, return current date dot is after sale start date and current date dot is before sale end date. So now that the condition part is more readable. So I have not resolved that else part, the bug here. So I'll be doing that in the next slide. But if you can see here that there is some piece of code which is common and which is repetitive. So we saw that. So this duplicate code being here is a problem because it is very it is extending the method too long, right? So what if we pull this out to a higher level? So if a piece is if is within sale period, then you add the sale discount, and if total price is greater than base price for discount, you add the additional discount which the high spenders get, that is 10%. So at the end you will be here I've resolved it because now you will be able to get the 20 plus 10 30% of discount. So if you see here, if I had shown this function, does this look better than in the previous one, or do you guys feel that the previous code was better? Yes. So with that, let us move on to the next requirement. So, so the smell in the previous slide was that having too many if blocks are going to be, so either you can decompose the conditional block or extract them into conditions so that they make some meaning, they are meaningful, so they have a meaningful function. So the new requirement here is, so we are going to be having a kind, this smell is kind of similar to the previous one. So the requirement here is that we need to have a reward system in our application. So this reward system is basically, it's going to give you every reward on purchase on your total price. And if you are a school student, you get a separate reward. Unlike the previous case, you will not be adding both the rewards together. So the reward points will be accumulated to the user and he can spend it whenever he wants. So if you see here, this also has too many if blocks. Like it's nested. It's so nested that you go in tree structure. So 3 levels inside that indentation, right? So now that if I had extended this code a little bit, it would have gone outside the screen and it will be very difficult for us to read through it. So the function is basically checking if the payment was successful and if back to school season, then if you're saying that you're applicable for the back to school season, then you must be a verified student, right? And then you allocate the reward. So I've not written the logic there. Imagine if there was some logic there, this function would have been even more bigger. I've just used print statements as placeholders for the logic. So and then else we do this, we do regular reward. So here what I can see is I've used the concept called as early exiting. So where you basically extract full. So this is somewhat similar to the previous case, but you are basically taking the condition, the corner cases or edge case conditions to the top of your function. So when as soon as you enter, for example, let us walk through this example. If your if payment is not success, you wouldn't even be required to go inside this function and look into some other details, right? You can just say that okay, you are done. You are not allowed to enter inside the function even more. So you can just exit the code earlier. So and then if you see here, then is back to school season and is student verified, then you allocate the reward student back to school reward and return. So what we can see here is you can see that basically I've flattened the nested conditions earlier. So the nested conditions are a bit uh, context. It takes a lot of conceptual power, and then if you see there is a clear separation of conditions. If you, what I mean by clear separation of conditions is that you can see the edge cases in the top, and you can see what is the functionality of your this function. Allocate reward is going to be allocating reward, but whether it's back to school reward or whether the payment was successful, those are clearly segregated in the initial steps itself, so that your code doesn't become messy with what the edge cases of the conditions are. Uh, So the next thing is functional arguments. So functional arguments are also kind of similar to if statements. They also take in a lot of conceptual work. Imagine that I have a function with two Boolean values. So the worst case, so you're writing some unit tests, and the worst case is that that function can be tested in 4 different scenarios with 4 different possible values, like true, 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 false, false, true, and false, false. Those. So this is just for 2 variables. Imagine if we have 5, 6 variables. It is not necessary that every time you will fall into this criteria where you get where the edge case scenario is very what to say. You get in all the possible combinations, but uh, you might end up having lot of test cases which are, say, it is very messy. So can we say that having 0 arguments is the best way? If you have 0 arguments, functional argument, your problem is basically solved. Right? But today it is very difficult to write any code with 0 arguments. So if you see, the next best thing to writing 0 arguments is having 1 argument, that is monoadic form of functions. So there is another thing. If you see in this slide, so we have ship order. Basically, you're going to be shipping an order to the customer, where you can see the customer name, customer address, order ID, total amount, shipping method, and there are other details. So, is it okay to have so many variables? Does this, if I had not written it down in a single line, if I had written down, so imagine if I had written everything down in a single line, it would have been really bad to look at the function signature, right? So what we can do is, from what I see, we can basically club the first 2 variables into a single object like customer, and the next set of arguments into an object called order. You see here, I have wrapped them up into a common, say, I've wrapped them down into wrap them up into a common object, so that this object can be passed down to any number of functions. I will be only using, for example, if I want the customer's name, I'll be using customer.name wherever I want, like whenever I want. If I'm not using customer in ship order, and if I'm doing it in, if I'm using it in one of the subsequent functions, I'll attract the customer object there only, so that it is very easy, and it looks more. It looks in a better way when you pass these down. Any questions? So, so until now, do you guys have any questions? Clear? Everything looks good. So here we come to the payment part. You need to be able to make payments with multiple methods. So one method is you can pay through card. You can pay. So I have listed down 3 methods here: cash transfer, UPI, and card. So tomorrow there might be a requirement that they want to split the card into 3 types. One is credit card, debit card, and food card, something like that. So this function, if you see here, this is basically writing down every logic. So there is the entire logic here. Here. So the problem is, if I keep extending this if block, so I can, when tomorrow if I am splitting card into debit card and credit card, I'll be basically splitting down this function into 2 more categories. So that is one problem which the function will keep on extending, and it will be very big before you realize that something is wrong. That is one problem. And the other problem is, when we see here, the pay method is basically taking in a couple of parameters. Say, does UPI, so for example, let us say I'm going to pay through card. Does UPI, do we need to collect the information regarding UPI number? Have you seen any application where you pay through card and you get the UPI number also? So it's always like you select an option and then it shows the bunch of details which are required for that particular option. So these are the 2 smells which are occurring in this code. and we will resolve them by replacing the conditional logic with the help of polymorphism. So what I've done is I have created an interface called payment method, which has an method which is like the contract is pay, and I'm going to pay with the amount X. And for card payment, what I'm doing is I've created for card kind of payments, I've created a class called card payment, which implements this payment method, and it takes down an argument as card payment. The constructor takes in card payment. So what happens is for card payment, I'll be passing down only the details for the card. For UPI payment, I'll pass down the details for UPI, and we can write down the logic here. So how this makes it better is each payment method is now a different class. So now if you have any functionality which is related to card payment which you need to do additionally, you can obviously perform in this particular class so that it doesn't make your original function very big. And how do we call this? So in the place where we call it, I have replaced the if else with a switch statement, which takes in the payment method. If it is card, what I'm trying to do is I'm trying to get the input value here. So that you don't have to get all the details. Get the input value for the card details inside the card, and we are trying to create a new card payment class. So an object for card payment and assign it to payment method, because payment method is our original contract. So if you see at the end, whichever is the case which goes in, you finally end up making one call. So payment method, because the dot pay method is going to be, it will at the runtime it will pick up whichever class which you select. So by this way we have avoided both the smells which we described earlier, right? We have another requirement, which is we need to be able to send the bill in WhatsApp, email, or SMS based on the customer's preference. So there is a bill abstract class for bill, which takes in the bill amount, and you have a method called beautify bill. Basically, beautify bill will arrange the bill in a better structure and it will return it. So we have something called as a WhatsApp bill, which extends the bill, and WhatsApp bill takes in the parameters to send the bill in WhatsApp. So do you guys see a problem here? It's not. So this is not in particular a smell, but this is somewhat, it affects your. So okay, I'll explain it now. So what happens is there is a what to say? The code is tightly coupled. If you see WhatsApp, sending a message in WhatsApp is tightly coupled with bill. So anything which you want to send in WhatsApp is always a bill in this format. Be it, for example, if it is email bill, it is always an email, a bill which is sent in the email. So tomorrow, say for example, we might get a requirement where we want to send the offers or the promo which the shop is trying to send out. If they want to send out some other details, we'll have to replicate this entire code, right? So that is not advisable. So basically, when inheriting, we are going to be delegating the work to somebody else. You see here, I have a contract for sender. Whoever is sending what bill will use this contract. For example, if you see email sender, and email sender is implementing the sender, and it has the logic to just send whatever is the parameter which it accepts. So for example, tomorrow if we have something like a discount or an offer, a special season sale which we want to send out, we can probably add another this thing called send and offer, so that you can send offer with the same logic. So this bill sender, looking at the base for the bill sender will have this object creation, will take care of the creation of sender. basically when you're instantiating the object for bill sender, you basically send the sender, that is whether it's going to be email or whether it's going to be an SMS or whatever it is, you initialize it and you give it to me. And the interface, so basically the when you're inheriting, you're basically delegating it to the sender contract consent. So by this way, one you have probably decoupled uh, the parent from the subclass, and this promotes more reusability. So reusable from the point that, as I mentioned earlier, you can reuse this if you want to send something else also. So here towards the end. So is there any problem which you guys can see with this code? Is this okay? Yeah, I feel that this is perfectly fine. This has no problem. It's just accepting an item, it's iterating through the items in the basket, and you're calculating the price and you're multiplying the price and quantity and calculating the total price. So you can basically replace these loops with the help of pipelines. So in Java particularly, you have streams for pipelining. Other languages also has their own way of doing it. What we are doing is, if you see here, we are using the map to double function, and then you are performing the same logic here, and then you are reducing with sum. Sum is a default method. If you want to reduce it to something else, you can use the dot reduce method. So by this way, you don't initialize a variable where total equal to 0. That part is not. This looks more cleaner, and when complex logic, when you are writing complex logic, this one, the second one, the one with pipelines, can help you can make it better readable. So if we try to use this map, filter, and reduce instead of the for loops, they will help you better readable, and then functional style is more readable when compared to the loops. So there is a statistics which I have taken out from a blog where the author of this blog basically gave a complex piece of uh, a for loop with some conditions, and then he asked everybody to uh, reply with an answer. You can see that, so the imperative style, that is the traditional for loops, had a better correct answer, that's 82%, and the average time which was taken for the correct responses was 83 seconds, whereas functional has slightly lesser number of correct response, and it has a better thing with them. So understanding functional style of programming can be little difficult, but over the period, if you start reading, it gives you a better structure. So you pass the input of one output of one function to the other function, and it's a pipeline way. So that gives a better way of readability. So to summarize today's talk, we saw what is a code smell and what are its effects, and how how they cause this problem with in the long run, how it affects our productivity. So and then we moved on about unit testing, and we saw the importance of unit testing when refactoring code and the advantages of having unit tests. So identification of code smells, and we saw a couple of techniques to identify and overcome these code smells. One was single responsibility. Any function which we take, it has to just do one thing. That one thing can be the smallest what it can do. For example, in the initial slides, we saw process order. The process order was also just doing one thing, but that one functionality had four different smaller pieces which was doing. So that is an indication that our functions are not smaller. And then we saw how we can make complex conditional logics. So because conditional logics can take a lot of conceptual power, so we saw the technique of early exiting there. We leverage polymorphism for replacing the conditional statements where you have repeated pieces of code and you wanted to differentiate based on one parameter. That is the example which we saw for pay method. We can basically use polymorphism to create different classes and have a common contract across all of them. We saw the effects of what code coupling can do. So basically, in this context, how code coupling can prevent extensibility of the code, and how it can be helpful to. So not code coupling, how breaking code coupling can be helpful to replacing it, reusability. So and finally, we saw how looping for loops can be replaced with pipelines. Any questions which you guys have in the slides or anything else in it? Questions? Okay, thank you. So there is a feedback from here. Please do in the